Hey everybody, I wanted to create this video to review the concepts that we are using in Lab 4, specifically the process of using fixed length subnet masks to divide up a range of IP addresses and allocate those addresses to subnetworks within an overall network. And I'm going to work through a couple of these, and hopefully it will help some of you who have expressed a little confusion on this topic. So we're going to start with a simple network. As you can see, we have essentially a network with a single router, and on either side, the left side and the right side, we have subnetworks. So subnetwork 1, which consists on the left side of PC0, PC1, switch A, and the port on router 1, F01. The right subnetwork, which is comprised of PC3, PC2, and switch B, and the single port on router 1, F01. So I'm going to be going through and giving you an IP address, a Class C, or not a Class C, but a group of addresses with a /24 CIDR notation. Okay, let's take a look. Okay, come on, here we go. Let's start off by just making sure that we understand the formula of 2 to the x equals the number of subnetworks, where x is the number of subnet bits that we borrow. Okay? As we go down, the problem is I'm going to give you this IP address. Specifically, it's a network ID of 192.168.43.0 with a /24. So we know that the first 24 bits of this address are network bits, and therefore this is a network ID because the host bits are all zeros. Namely, the host bits in the last octet, the fourth octet, are all zeros. And we can see that here. Okay, if I denote our network bits with N's and our host bits with H's, you can see that we've got 24 network bits and we've got 8 host bits. By using the formula 2 to the H bits, okay, which is different than this formula we just reviewed up here. This one tells us how many subnetworks we're going to have. This one is going to tell us how many hosts we have. And we do 2 to the host bits minus 2. So the number of host bits is 8. 2 to the 8 is 256. Minus 2 gives us 254. Okay? And so that's going to be equal to 254 there. Maybe I should kind of write that out. So 2 to the 8 minus 2 equals 254. And let me get over here and fix this. Okay, there we go. So 2 to the 8 minus 2 gives us 250 hosts. So that's how many host addresses we have to use to split up amongst this entire network, of which there are 2 subnetworks. So my next question, and I've already answered it, how many subnets are there in this network? And you can see that there is a subnetwork on the left and a subnetwork on the right, divided by this router. Every connection to a router is its own subnetwork. Okay? And as a subnetwork, it must have a unique subnet network ID or network ID. Okay, so in this particular network diagram, we have two subnetworks. Next question, how many subnet bits do I need to borrow, okay, to get that number of subnetworks? So I need to borrow a bit from these host bits here. If we go, I need two subnetworks, okay? So if I go and I borrow one bit, 2 to the 1, namely the one bit I borrowed, equals two subnetworks. So the number of, again, the number of bits that I must borrow is just 1, okay? And there it is. I use the S to simply delineate the fact that this is slightly different than your standard network bit, although it is included in the network bits. And at this time, I'm actually changing the CIDR notation from a /24 to a /25. So let's continue on. So next, now again, this is what our network subnet mask looks like, okay, consisting of, no, that's not right, the 25 network bits, and now only 7, okay, host bits. So what is the value of this bit right here? Okay, the value is, the rightmost value of our subnet bit is 128, which becomes our block size, and we know that our blocks are then 0 and 128. If we use our standard table calculating our network IDs, our first, last, and broadcast addresses, this is what we come out with: 0 and 128 for the network IDs, and then the appropriate first of 1, and then 126 for the last, 127 for the broadcast, 129 for the first and the second block, and 254 for the last, and then finally for the broadcast. So the last block is 255. So I've identified my two blocks. Now I need to allocate these addresses for each block to their respective networks. So my first network, let's bring that back. My first network on the left-hand side, that's going to go to the first block with addresses between 1 and 126. My second network, which is on the right-hand side, is going to go to the second block of addresses. And let's look at how I allocated these. So as we go down, I've got device, port, and IP address. So on my first device, PC0, on the far left-hand side, I'm allocating an address out of the first block, and I'm just, without any pattern, just to show you that there's no right or wrong way in which you apply your IP addresses, I'm selecting address 67, and you'll notice that's between 1 and 126. Then for PC1, I'm going to give PC1 IP address 56. Again, it's within that range of 1 to 126. Then we're going to go to switch A. Now switch A has 3 ports, F01, F02, and F/24. I do not want to give them individual IP addresses. What I'm going to do instead is I'm going to give VLAN1, which encompasses all 24 ports on switch A, and I'm going to assign that 190.25.43.25, again within our range of 1 to 126. Finally, we have the port on the router 1, which belongs to our left network here. So I've got to give that an IP address. So router 1, port F00, I'm going to give it 126. Again, it's in that block, that first block there. Okay. So I've assigned all of the needed IP addresses to the various devices on the left side network. Now I'm going to assign the second block of addresses to the right side network. And here we go. We're going to start with router 1. Router 1 has that port F01 that is on the second network. And I'm going to assign it 190.25.43.254. Again, 254 is within that range. In fact, it's the very last address, and that's just fine. Moving on, I've got switch B. Again, I'm going to assign it to VLAN 1 on switch B as 190.25.43.240. Again, within the range of the second block. Moving on to PC3, I'm going to assign that 130, and PC4 I'm going to assign 140. Okay, I hope that is helpful. I will work through 2 more of these problems, and as always, I hope that you will ask questions when it is not clear. Okay? All right. Okay, folks, here's our next problem. And in what you see on the left-hand side is we've got a new network. You'll notice that the connection between switch C and router 01, they're colored red. Don't even think of that. Don't worry about that. But as you can see, one of the things that we've got here is we have 3 connections to our router. And as I've said before, every connection to a router is going to be its own network or own subnetwork. The only time this is not the case is when you make a connection with a console cable. That is a completely different type of connection. It is not what we refer to as a network connection. So, all network connections to a router are comprised of different subnetworks. So again, in this problem, we've got 3 subnetworks to deal with. All right, let's move over to the right. And if you recall, our formula 2 to the x is equal to the number of subnetworks, where x is the number of subnet bits that I must borrow. Okay, moving further down, our second problem, same network ID as we had before, and again a CIDR notation of /24, meaning that there are 24 bits in the subnet mask and 8 host bits. So as we go down, I display that here. You'll notice that we've got our 24 network bits and our 8 host bits. Again, if we use the formula 2 to the number of host bits minus 2, that's going to give you the number of hosts. So I need to correct this, because the number of hosts here, the number of host bits for this problem is going to change. But right now it's at 254. So how many subnetworks are needed? Well, based on our diagram on the left, I need 3 subnetworks. So we'll put that in. I'm going to need 3 subnetworks. How many bits do I need to borrow? Well, going back up to our formula up here, 2 to the 1 only gives me 2 subnetworks. 2 to the 2 gives me 4 subnetworks. And that is enough to handle the 3 that I need with an additional 1. Okay, so again, the number of subnet bits that we are going to borrow is going to be 2. And as you can see, 2 to the 1 only gave me 2 networks. 2 to the 2 gave me 4, which is what we needed. And now you can see that I've got 26 network bits, 2 which we borrowed, designated by the SS there. And that leaves us with 6 host bits. 6 host bits is going to give you 2 to the 6, which is right. 2 to the 6 is 64 minus 2, which is 64 for each block, okay, or 62 for each block. So now what's the value of the rightmost bit? Well, the value of the rightmost bit right here, okay, what's that value? Well, it's not 128, it's 64. And our blocks then are 0, 64, let's get this right, 0, 64, 128, and 192. Okay, so those are going to be our potential network IDs. So let's go down and complete our table. Here are our network IDs, and we're only using the first 3. Okay, could I use the last 3? Yes, you could. All right. In fact, you could use the first, you could use the third, and the fourth. It really doesn't matter which of the 4 you use. You just need 3. Okay. So I'm going to start out by using the first 3. Okay. So your network IDs are 0, 64, 128, and 192, just as we said, you know, based on the block size of 64, we did the increments from 0, 64, 128, 192. So my first address on the first network, and I'm going to be lettering these networks, okay? So first address is 1, then I've got 65, then I've got 129, then I've got 193. Okay, I'm going to jump out to the broadcast address, 255. This is going to be 191. This is going to be 127. And this is going to be 63. And that should be 127, not 128. There we go. Does that all look right? Yes. And then we'll put in our last addresses, which will be 62, 126, 190, and 254. So again, we only need 3 of these blocks. We don't need the 4th block, but I put it in there just to show it. And now what I need to do is I need to go and I need to allocate these address blocks and the addresses to the devices. So the network on the left I'm going to designate as network A. Network B is going to be the network on the right, and network C is going to be this network down below here. Okay, so let's look at our devices. Here are the various devices and the ports. So we've got your network identifier A, and then your devices, then your ports. So on PC 0, I need something between 1 and 62. So I'm going to give it a dot, I'll give it the whole thing. Let me go up here and get it. So I'm going to give it a 1. Okay. PC2, I'm going to give it a 2. VLAN 1 on switch A, I'm going to give that a 3. And router 4, or router 1, port F00, I'm going to give that a 4. Okay. Now notice we're looking at the port on router 1, F01. That belongs to network B. So I have to get an IP address out of the second block from 65 to 126. So I'm just going to go in. First address in that block is 65. I'm just going to take that. Next, we've got port on router 1, F10, and that port belongs to network C. So I have to take out of an address out of the third block. So I'm going to take 129. I'm going to take the first one. Now we're back to network B and switch B. Okay, so network B, switch B, VLAN 1. So I'm back to the second block here. I've got to take something out there. So I'm going to take 66. And next, we're going to do PC3. I'm going to make it easy on myself. 67, then 68. Okay. Let's move on. Now we're going to go to our network C, which is at the bottom here, and our switch VLAN 1. That's got to be out of the third block, starting at 129. So I'm going to use 129. And then we'll go and we'll do PC4, and we'll do 130 on that. Then PC5, and we'll do 131. Okay. So again, I've used a different pattern for assigning IP addresses, whatever pattern you like, as long as it's within those ranges. One of the things that I failed to do in this diagram up above here was give you the show you the new CIDR notation for these. Okay, so I'm going to put this in, and then I'm going to go back to our previous problem and put those in as well. This is now a CIDR notation of 26 because we have, one second, because if you recall, we borrowed 2 bits. So when you count up all of the network bits, including the SS's, okay, that gives you 26. All right, let's go back to our previous problem and correct that table as well. I will ultimately save this information to a file so that you'll have it and you can look at it as you watch this video. So let's see, where are we here? Okay, so we want to do CIDR on this. And if you recall, we only borrowed 1 bit here. See that 1 bit? So how many bits are in my network bits? There are 25. So our CIDR notation is going to be /25. And this is why we call it a fixed length subnet mask, because the length of the subnet masks for each subnetwork are the same. Here they're 25. Down below in this problem, They were all 26. Okay, they're a fixed length. Okay, so I hope that that helps you with the second one here. Like I said, I will be taking this file. By the way, it's a WordPad file. I believe it'll open up under Word. But I use this because Notepad does not allow me to use the exponent by raising something. It doesn't allow me to do this. Okay, so I used WordPad instead. So, all right. So that's our second example. We'll now move on to our third. Okay, so here is our third example. And the first question to ask is, how many subnetworks are within this network? And as we look at the router, we notice that there are 4 connections to the router. Therefore, there are 4 subnets. Therefore, each subnet needs a unique network ID. With respect to the ports on the router, you'll notice that we're using port F00, 01, and this should actually be port 1/0. Okay, and then F1/1. Okay. You'll notice that we've got 4 switches: switch A, switch B, switch C, and switch D, and these will kind of denote our network. So we've got network A, then we've got network B, or I'm sorry, network B is actually, this is our network B right there. Then we've got network C down below here. And then finally, we've got network D up above. Okay? 4 networks, or 4 subnetworks, each with its own network ID. All right, so let's bring up our WordPad. And again, I remind you of our formula here. 2 to the x equals our number of subnetworks. So the question we're going to be asking is, how many subnetwork bits do I need to borrow? Our problem, again, we're working with the same network ID as before with a /24. And as we look at this, we see the 24 bits, 24 network bits, and we've got the 8 host bits. The 8 host bits give me 254, but we're going to subdivide this. And the question becomes, how many subnetworks are needed? Well, the answer is 4 here. And how many subnet bits do I need to borrow? Well, if I borrow 1, that gives me 2 subnetworks. If I borrow 2, it gives me 4, which is what I need. So I'm going to be borrowing 2 subnet bits. Okay? I'll just check something here real quick. Yeah, I did that right. Okay. Okay, so now our subnet mask looks like this. And really, this is very much like the previous problem that we had, where we now have 26 subnet bits that are set, and we only have 6 host bits. So again, we ask that question, what's the value of that host bit? The value is, as it was in the last problem, it was 64. And again, we go by our multiples of 64, 0, 64, 128, 192. And then we come up with our table of network ID, first, last, broadcast, and CIDR, and they're all the same. Okay? Now I'm going to go about and I'm going to assign IP addresses to all of my devices. So the first one is going to be, I'm just going to put in the last octet. I'm not going to bother putting in the 190.25.43. I'm just going to put in the value for the last octet. So the value for the last octet here is going to be, because it's coming out of the first block, and you'll notice that I've got the network identifier here, which is, this is network A. So we're going to be picking out of the first block, or the first range, 1 to 62. So I'm going to do, let's say I'm going to do 62 on this, then I'm going to do 61, then I'll do 60, and I'm going to put in 1 here. Then we have F01, which is this port right here belonging to network B. So I have to pick out of the second block of addresses, and that's going to start out with 65. So I'm going to pick 65 just for the hell of it. Then we've got network C on F10 right there, F10, and that comes out of the third block of addresses, so I'm going to give that a 129. Then we've got network D on F11 right there. There's F11, and I'm going to give that out of the fourth block of addresses. So the first one there is going to be 193. Then we're back to network B, switch B VLAN 1. So I'm in my second block here, and let's see, I gave 65, so let's do 66, then 67, 68 for network B. Now we're into network C, so that's coming out of our third block right there, 129 through 190, and I already gave away the 129, so next is going to be 130, then 131, then 132, and then finally I've got network D. And I already gave away for network D, I already gave 193, so now this is in the last block. I need to give, the next one will be 194, $195, and 196. So there's the answer for the third problem, and this will be it. Again, if you have questions, please don't hesitate to ask. We can easily get together online, and I'm sure that we can answer your questions within just a few minutes. Okay? All right, gang. Thank you.